Math 102, Chapter 1, Exercise Questions. In this video, I'm going to go through the typical questions I get for each of the sections when I'm teaching Math 102. So you can see down here, I have listed the different sections. And so you might take a look right now and see if the question that you're looking for is listed here. So I'm going to go through in succession here in this video, and I'm going to try to make a way so you can skip to these different sections easily. But you can go through and see all the question numbers that I have for each of these. So section 1.1, here are the questions I'm going to do, 1.2, so on and so forth. So take a look there and see if your question is there. If it's there, go ahead and scroll the video forward, or like I said, I'm going to try to find a way on YouTube to make it so you can just jump right to it. May or may not happen. But, okay. So let's get started with section 1.1. And in 1.1, these are the questions I usually ask. First is question 26. We're asked to do the subtraction with a decimal. Well, when we have a decimal in a subtraction problem, what we do is we do this like a normal subtraction problem. We're just going to bring this decimal straight down in our answer. So basically, the decimal is going to end up right there in our answer. And now I'm just going to go ahead and subtract. So I'd say 9 from 2. Well, I can't do it, so I'll have to borrow from the 3, which will make that a 2, which makes that a 12. 12 minus 9 is 3. And now I would try to take 8 away from 2, and again, I can't do that, so I'm going to borrow from this 8, which will make it a 7, make that a 12. Now I can say 12 minus 8 is 4, and then 7 minus 3 is 4. So you can see I'm just bringing my answer straight down here as I subtract, then bringing the decimal straight down. One thing that we want to do, especially if we're in the nursing program or in the allied health fields, is we want to make sure we put a 0. I'm going to move this decimal a little bit. I want to make sure we put a 0 on the front. It's really easy to miss that decimal if we don't put the 0 on the front, so make sure you put that in there. Okay. Question 28. Now we're multiplying. Well, multiplying is a little different. What we want to do here is we want to just make sure there are as many decimal places in our answer as there are in the problem. So this is what that means. In my problem, notice I have 1 digit here behind the decimal, 2 up here, so altogether I have 3 digits behind the decimal. That means down here in my answer, I need to also have 3 digits behind the decimal in my answer. So I'm going to multiply and first ignore these decimals, and I'm going to put those in at the end. So I'd say 8 times 4 is 32, carry the 3. 8 times 5 is 40, plus 3 is 43, carry the 4. 8 times 6 is 48, plus 4 is 52. Okay. Now I'm going to go through and multiply by 3, but I need to make sure I start my answer directly below the place value of 3. So you can put a 0 here or an X, but we need some sort of placeholder there. Okay, now I'm going to go through and follow the same pattern with 3. So 3 times 4 is 12, write the 2, carry the 1. 3 times 5 is 15, plus 1 is 16. Write the 6, carry the 1. 3 times 6 is 18, plus the 1 is 19. And now I'll add these up, going straight down. So 2, 5, 8, 14, carry the 1, and then 2. So as I mentioned at the beginning, 1, 2, 3 digits behind the decimal in the problem. So I need 1, 2, 3 digits behind the decimal in the answer. So 24.852. Okay, question 31. We're doing division now, long division here. And so the first thing I need to do when I'm doing long division is it really complicates things if I'm trying to divide by a decimal number. So what I do is I move this decimal over until it becomes a whole number, which in this case is just one place. Had I had to move this decimal more than one place, that's fine. I just keep moving it till it becomes a whole number. When I do that, I'm going to rewrite this problem. So instead of 3.4, I'm going to be dividing by 34. Now, because I move this decimal on the outside, I need to move this decimal in here to match. So notice we moved it one place to the right. So I'm moving that guy one place to the right. So 7, 5, 1, 5, point. And I'm going to add some zeros here because what I'm supposed to do, and I needed to put that in my answer here, I'm supposed to round to the hundredths place here. And I should have put that on those answers over here. So let's go back to these problems here. I was supposed to round all of these to the hundredths place. So let's see, 26.443. Here's my hundredths place. The 3 is going to tell me to keep that digit in the hundredths place the same, so my answer here is 0.44. Here, rounded to the hundredths place, that's the 5. The 2, again, is going to tell me to keep that 5 the same, so I'd have 24.85. notice in order to round this digit in the hundreds place, I need to have this digit in the thousands place. So when I'm dividing over here in this problem, if I want to round in the hundreds place, which is this spot right here, I need to know the digit in the thousands place. So basically what we're going to do is we're going to divide to one more place value than we're rounding, and that's always the case. So now that I got it set up, let's talk about doing division. So here's four-step thing that we use for division. Goes into, multiply, subtract, bring down. Okay, and that process just kind of keeps happening over and over again. So let me show you how that works. So the first thing I would say, well, 34, will that start dividing into 7? No, it won't. So I'm just going to basically, I could put a 0 up here, or I can skip that piece of the division. I'm just going to skip it and say 34 won't start dividing in at 7, but it will start dividing in at 75. And that's going to go in there 2 times. So that's the goes into part right there. It's going in there 2 times. Now I'm going to multiply 2 times 34, which gives me 68. Now I'm going to subtract. That's 68. 75 minus 68 is going to give me 7 again. And then bring down is my next step. So I'm bringing down the next digit, which is the 1. Once I bring down, notice we're going to go back over and the whole cycle repeats again here. So I'm going to say 34, but instead of dividing up here now, I'm focused down here. So I'm going to say 34 goes into 71. Well, that goes in there twice again. And then I'm going to multiply 2 times 34, 68. Then I'm going to subtract, which will give me 3. Then I'm going to bring down the next digit, which is a 5. Okay, so let's take a look again. Now I'm going to say, all right, starts over again. 34 is going into 35, goes 1 time. 1 times 34 is 34. Subtract, I get 1. Now I'm going to bring down this next digit, which is a 0. So then I would say, okay, 34 is going to go into 10. Well, it's not, because 10 is smaller than 34. So what I need to do is put a 0 up here. I need to have a placeholder for every one of these things. I'm going to put a 0 up here and bring this next digit down to make this 100. Another way to think of this is I could say at this point with 10, 34 goes into 10 0 times. So that's another way to end up with a 0 on the top there. Either way, but basically when we have this number out front that's larger than what we have down here, we put a placeholder 0 and then bring the next digit down. Okay? Once I bring the next digit down, the whole thing starts again. 34 is going to go into 100. I don't think that's going to go 3 times. Nope, that would be over. So that's going to go twice again. And then 2 times 34 is 68. Subtract, and let's see, 100 minus 68, that would give me 32. And then I'm going to bring down the next digit, which is the 0. Okay, so 34 is now going to go into 320. It's not quite going to go 10 times because that'd be 340. It's going to go 9 times. Now, I could continue, multiply by the 9, subtract, and keep going, but notice I can stop right now because what I've got is I've got this third place value here, my thousands place, which will tell me now how to round the hundreds place. So this 9 is going to tell me now how to round that digit in the hundreds place. So I don't need to continue dividing at this point. Now I'm ready to go ahead and write my answer. And my answer then is going to be 221.03. One thing I forgot to mention, but I just did in my answer, is that this decimal then, once we get that decimal in its spot, it just moves straight up. We line those up with division. So when we're doing addition, subtraction, and division, we line the decimals up, basically, for our answer. So here's my answer for that one that's rounded. And I should box this one in here as well, that 24.85. All right, let's take a look at question 34 now. A survey company finds that there are approximately 610 pine trees per acre in a national park. If there are 22.6 acres in the park, approximately how many pine trees are in this park? So, you know, I think one thing that we always want to do when we're doing a story problem is you kind of want to put yourself in the story problem and kind of think about what's going on. So we know this, and I'm just going to draw a little acre here. So I'm just going to say that little box is an acre. And I know that there's 600 pine trees on there. If you want to draw yourself a little pine tree to get a visual, Let's find 2. So there's my little pine tree. We know there's 610 pine trees on one of these acres. Now it tells me that there's 22.6 acres. How many pine trees? Well, if I had 1 acre, I'd be at 610 pine trees. 2 acres, I'd have another 610 of these guys here. So one way to get to that answer would be to add these together, 610 and 610. If I had 3, add 610 again, add 610 again. Well, in mathematics, anytime we recognize a situation where we're doing repeated addition, the quickest way to get to our answer is multiplication. That's why we have multiplication, is to perform repeatedly adding the same thing. And so that's what we're doing here. But we don't need to take a whole number of this. We need to take 22.6. So all I'm going to do is I'm going to take 610 times 22.6. and multiply this out and get my answer. So again, since I'm multiplying, I'm going to ignore the decimal. 6 times 0 is 0. 6 times 1 is 6. 6 times 6 is 36. Going through with a 2. First I'll put a 0 down here to hold my place. 2 times 0 is 0. 2 times 1 is 2. 2 times 6 is 12. Now I'm going to put 2 zeros to hold my place now, because notice I want this answer to start directly below it in my answer here. So let's see, multiplying by the 2, well heck, I'm going to get the same line that I got right there. So I'm going to get, after these zeros, I'm going to get 0, 2, 2, 1. So I'm going to add this together now. 0, 6, 8, looks like 7, 3, 1. Now, in my problem, I had 1 digit behind the decimal, so I need 1 digit behind the decimal there, even if that's a 0. So we would know that there are, since this is a story problem, we want to put some meaning to this word, this number here, 13,786 pine trees in the park. And since this was kind of a rough estimate, let's say this too. Let's say approximately. So anytime we're doing a story problem, we want to make sure we have place some meaning on the number, because there's always going to be some sort of meaning. Okay, last problem in section 1.1 is 35. A company that restores land in forested areas can restore about 2.5 acres per month. How long will it take this company to restore a 40-acre tract of land? So again, let's think about this. We're restoring land, and in 1 month we can do 2.5 acres. So this is what I would say. Here's 1, 2, and maybe a half of an acre is what we can restore. And we're planting trees on here or something like that. So in 1 month, this is what we can do. So in 2 months, we could do 2.5 and 2.5 again. We could do 5 of those. And so one way to get to this answer is, again, repeatedly add 2.5 acres over and over until we got to 40. So that's one way to do it. Or we could use multiplication, because that's what this is here, is multiplication, because we're repeatedly adding 2.5. So we could take 2.5 acres and guess and check and multiply by numbers until we get to this 40-acre amount that we want. But there's a quicker way to get to that answer, and that's using division. So we do want to find out how many times we need to multiply this 2.5. So we are actually technically looking at multiplication here, but the quick way to get to this answer is to divide. So what we want to do is we want to take 40 and divide by 2.5. And again, we're going to set this problem up so that I'm dividing by a whole number in the front. So that'll be 25 into, and I move this decimal one place to the right, it will now become 400. Move the decimal up like that, and I'll say, okay, 25 is going into 40. Nope, not quite twice, just once there. So 25, subtract, let's see, 15. 30, 15, yep, 15, bring down the 0. Now I'm saying, okay, 25 is going into 150. That's going to go 6 times. So then it's going to take 16 months to restore 40 acres. All right, let's take a look at section 1.2 now. Let's take a look at section 1.2 now. Just one question here that I usually answer in section 1.2. That's question 34. An accountant started with a balance of $415. She posted debits of $135 and $380 and one deposit of $85. Well, a debit means we're taking money out of the account. So we would treat these as negative numbers. Both of those as negative numbers. So we can either add those as a negative value or we can just subtract. I think it's easier here to subtract, but technically this is what we've got. We've got 415 plus this debit of negative 135 plus this debit of negative 380 and then plus a deposit, which is actually a positive to the value to the account, plus 85. Okay? So a couple ways of doing this. We can take and add the positive numbers together and then subtract these two, and I think that's probably the easiest way to do it. Or we could just work left to right. 415, subtract 135, get that answer, subtract 380, and then add 85. Let's start by adding 85 and 415 together. So I'm going to take my positive values, kind of combine those, and while I'm at it, why don't I take my negative values and combine those as well. So let's see, 415 plus 85. So I'm over here thinking now, 415 plus 85, and that's going to be pretty good because that's going to work out to be a nice whole number. 10, carry the 1, 10, 1. Okay, that's 500. So now I've got 500, and I'm going to take away from that 135. Let's see, if I was taking away 100, that would be 40. Sorry, 400. Well, we'll just borrow. 4, 9, and 10. So what I did is I said, all right, I'm borrowing from the 5, which would make this a 10, but I know the next step I'm going to have to do is borrow for this 0 over here. So this was a 10 for a second, but I borrow 1 from it, which makes it a 9, and that last digit now is 10. So 10 minus 5 is 5, 9 minus 3 is 6, 4 minus 1 is 3. So now we're at 365 when we got down to this 135. So now I'm going to take 365 and subtract 380 from it. Well, you can see we're going to end up in a negative value here. Do you see I'm taking away more than I started? So let's just go ahead and do this. I know I'm ending up with a negative value. If I want to subtract and find the difference here, it's going to be to my advantage to reverse this now as I'm calculating what the difference is. I know it's going to be negative. Now I'm going to calculate the difference. 380 minus 365 is going to give me 15. But I know that that is 15 negative, and I want to put a dollar sign on that. So negative $15 in the account. Okay, section 1.3. Just one question here as well, question 46. So let's go through this one. You're one of 3 equal partners in a company sharing expenses and profits. So you want to stop right there. We're doing a story problem. You want to see yourself with one of 3 equal partners. So there's 3 partners in our company. You're one of them. Okay? And that's one important thing to do when we do story problems. You don't read this like a novel. You read a little piece of information, you stop, you think about it, visualize what's going on, and then once you've got a hold of that idea, then we can move forward. So here we are, one of 3 partners in a company. So let's go on to part A here. In your first year of business, your company takes or makes a $120,000 profit. What is the net result for each partner? Well, there's 3 of us, so all we're going to have to do is take this $120,000 and divide it by 3. And if I do that division, I'll get $40,000 profit for the first question. And let's put a dollar sign on there as well, since we're talking about money. All right, part B. In the next year of business, your company makes $270,000 profits. What is the net result for each partner? So again, we're making money here. So I'm taking this $270,000, dividing it by 3, and that's going to give me $90,000. $90,000 in profit. All right. Question C. The economy declined and the demand for your product took a plunge. The third year of business, your company experienced a loss of $480,000. What is the net result? Well, that's no good. So we're going to take this $480,000, but it's a loss, so we got to treat that as a negative value. We can no longer say that we lost all this money and that we're still going to be making money here. We're losing money, so that value has to be negative. Again, we're dividing it by 3 because there's 3 people in the partnership here, and if we do that, that's negative $160,000. Ouch. Not a good year for me, or whoever this is in the partnership here. So negative $160,000. Let's go down and look at question D now. Over 3 years, what is the net result for each partner? So we need to now look at the overall business and see where each partner stands. Well, each partner is going to have the same outcome that I did or that you did when you're thinking about yourself in this partnership. So what we did is we first made $40,000, made $90,000, but then we lost $160,000. So we need to kind of figure out what happened overall. I think the first thing we want to do is add these two together. Add the 40 and the 90, which would give me $130,000 in those first 2 years when things were looking great. But then I've got this negative 160 on there, so I'm actually going to be subtracting $160,000 there. And so you can see I'm going to end up in a negative spot. Let's see, 130, if I took 160 from that, that'd be negative $30,000. So negative $30,000. I think probably I should put the negative sign in front of that dollar sign there. A lot of times what you'll see people do, just so that they don't miss this negative sign when we're talking about monies in terms of profit and loss is always put in parentheses like this. So this is how this would actually be written. If an accountant or on some sort of books it was written, you put it in parentheses, that would indicate that it's negative. All right, taking a look now at section 1.4. First question I usually answer in section 1.4 is question 31. Jim Hubbard treats his farm acreage using a new sprayer for fertilizer. So you want to stop right there. You see the farmer, Jim Hubbard, he's out there spraying stuff all over the field and fertilizer. I'm sure you've driven past that before, so you've got a good visual on that. Okay? So his new sprayer is equipped with a 1,000-gallon sprayer tank. So you can see his tractor or his sprayer out there, and it's got a 1,000-gallon tank on the back. When done spraying, Jim has used 2 3/4 tanks of the mixture. So how many gallons did he use? That's our first question here. So he's got a 1,000-gallon tank. He uses 2 3/4 tanks. So this is a question that comes up all the time, and it comes up in a lot of different forms. What we really want to find is we want to find 2 3/4 of the tank, really. And so this happens a lot. And with fractions, anytime we're trying to find a fractional part of something, we multiply. And that's a little counterintuitive. A lot of times people think they need to divide, but that's not the case. If we're trying to find a fractional part of something, you multiply by that fraction. I think the easiest way to think through this is to first do 2 tanks, then do 3/4 of the tank on the last round. So if we did this, 2 times 1,000, that would give us 2 tanks. And then what we want to do now is the next time find 3/4 of that third tank. So we would just go 3/4 times 1,000 again. And you can see I'm doing exactly what I just said. To find a fractional part of something, I multiply. And notice, it's the same thing that I did when I had a whole number here. To find a whole number part of something, or find a whole... So it's the same thing I did here. Notice here I multiplied 2 times 1,000 to get the 2 whole tanks. And here I take 3/4 times 1,000 to get 3/4 of the tank. So 2 times 1,000 would give me 2,000. 3/4 times 1,000, well, let's write this 1,000 as a fraction. So I'm going to write that over 1. And I could multiply straight across and get my answer, but notice, remember what I've told you is we can simplify. Check to simplify when we're multiplying fractions first. And notice 4 will go into itself. I also know that 4 goes into 100, which means 4 is going to go into 1,000. So I'm going to divide a 4 out here, which will leave a 1 there. And when I divide 1,000 into 4 equal parts, that would give me 250. So now to find my answer, what I'm going to have is, in my denominators, I have a 1 and a 1. So that's going to give me 1. In the numerator, I'm going to have 3 times 250. Well, 3 times 250 is 750. I'm going to erase this here. So that's 750. So now if we did 2 3/4 tanks, that would be 2,000 plus 750. So 2,750 gallons. Okay, important takeaway here is that to find a fractional part of something, we multiply by that fraction. All right, let's take a look at B. If the sprayer is adjusted so that each tank treats 80 acres, how many acres did Jim treat? So every tank, every time he sprays a tank, he treats 80 acres. So we want to know how much he treated if he did 2 3/4 tanks. Well, that's really almost the same problem we just got done doing. We want to take 2 3/4 now, not of 1,000, but of 80. And I think the way to do that is the way we just got done doing that. So we'll take 2 times 80, and then we'll take 3/4 times 80. And I'll write that 80 as a fraction over 1. So let's see, 2 times 180, that's 160. And then here, I'm looking to simplify again, and notice 4 is going to go into itself, and it will go into 80. It goes into itself once. It goes into 80 20 times. So 3 times 20 is 60 over 1, which is just 60. So to get my final answer here, I'm going to take 160 plus 60, which would give me 220 acres. All right, let's take a look now at question 32. How many minutes are there in 5/6 of an hour? So notice we're trying to find 5/6 of something. To find a fractional part of something, I'm going to multiply. So what I'm thinking here is I need to take 5/6 times 1 hour. Well, that's kind of funny because they're asking us now how many minutes are in that hour. So I think it's going to be to our advantage now. Instead of thinking about this as 1 hour, thinking about this as 60 minutes and 5/6 of 60 minutes. And so that's what we want to do to solve this problem. 5/6 times 60 minutes. I'm going to write this 60 as a fraction, 60 over 1. And then notice again, we've got 6 that will divide out there before I start multiplying. Save myself some time and work here. 6 goes into itself once, goes into 60 10 times. So that is going to be 50 minutes. All right. Question 33. What fraction of an hour is 7.5 minutes? And this is a tough question. So anytime we're asked this part, what fraction, anytime you see this in a question, think about the fraction as the part over the whole, because they're asking you to describe the situation using a fraction. And in its most basic forms, a fraction is a part over a whole. So let's take this part over the whole and apply it now to this problem that we're working on here. So what fraction of an hour is 7.5 minutes? Well, here are the two things we're looking at. We're looking at an hour and we're looking at 7.5 minutes. Which is the part? Which is the whole? Well, if you said the hour is the whole thing and the part is 7, and let's think about this as 7.5 minutes. I think that'll be a little bit easier to think about. Now, anytime we're working a math problem and we've got mixed units in here, we're going to need to change them to the same units. One option here would be to change 7.5 minutes into a part of an hour, but that's going to be a lot harder than turning this hour into minutes. So what I want to do is I want to take 7.5 minutes and then compare that to 60 minutes. Now I'm comparing units that are the same. Okay, and one thing I want to do now, once I get this information now I've kind of answered this thing. I've got a nice answer here for the part over the whole. I've got the units the same, but like anytime we're working with a fraction, we always want to see if we can simplify it. And this next step is kind of tricky. So 7.5 and 60 share a common factor. 7.5 actually divides into 60 evenly. So I'm going to reduce this fraction or simplify this fraction like I would do any other fraction by dividing out the common factor, which is to divide by 7.5, the top and the bottom. And on the numerator then, I'll get 1. And in the denominator, 60 divided by 7.5. And so what fraction of an hour is 7.5 minutes? It's 1/8. And then we would say 1/8 of an hour. So the next thing we're going to look at is the class project. So you're going to be working on the class project here at home, and sometimes the 1.4 class project causes or creates some questions here. So let's take a look here. So your club plans to sell soda at a basketball game. So you can see that. See the club selling the soda. You're behind a table or you're behind a booth or something like that. You're selling the soda. 3 sizes will be sold. 16, so picture that cup, 20, and a 32-ounce cup. So you're going to sell 3 sizes of soda at the basketball game. Again, we're working a story problem here. We want to put ourselves in that situation. 1/3 of the volume of each cup is ice. So visualize the cup now and see that it's a third full of ice before we're going to pour the soda in there. So if it's a third of ice, then it's going to be 2/3 of soda to fill the whole glass. Okay? So what we want to do now, since it says here the Booster Club is donating the cups of ice. So we don't have to pay for the cups, we don't have to pay for the ice, but we need to figure out how much actual soda are in these different sizes. Since they're not all going to be soda, since 1/3 of this is going to be ice in all of these cases, we need to figure out how much ice is in the cup and then how much soda is in the cup, because then we can start to figure out what to charge for the sodas and how much profit we're going to make from these sodas and stuff. So basically what we want to do here is we want to find out the ounces of ice, okay, and the ounces of soda. I want to find 1/3 of something. I want to find 1/3 of something, and then I want to find 2/3 of something. Well, 1/3 is the ice. So if I'm looking down here and I got this 16-ounce cup, 1/3 of that is ice. How do I find 1/3 of 16? Notice when I ask that question, 1/3 of 16, I'm asking how to find a fractional part of 16. So to find a fractional part of something, I multiply, just like in those problems before. So I'm going to take 1/3 times 16. And so I'm going to write 16 as a fraction, 16 over 1. Now, I think it's going to make sense here to write these as a mixed number, because as an improper fraction, this is not going to make a lot of sense for us. So let's see, 16, there's no common factors to divide out here, so I end up with 16 over 3. And let's look at that as a mixed number. 3 goes into 16 5 times with 1 left over, so that would be 5 1/3 fluid ounces for the ice. Okay? Once we figure out how much ice there is in there, we could subtract 5 1/3 from 16 to get this next thing. That would be what's left is the soda, or we could just find 2/3 of 16. I'll just go ahead and do that since I think that's easier. So I'm going to find 2/3 of 16. This will tell me how much soda is in the cup. So let's see. Nothing to divide out here, so I'm just going to multiply straight across. 2 times 16 is 32. 3 times 1 is 3. Again, let's turn this into a mixed number. 3 goes into 32. It goes 10 2/3 fluid ounces. All right, let's double check to make sure our calculations were correct. If they're correct, they better add up to the whole thing that's in the cup, which is 16 ounces. So if I take 5 1/3 plus 10 2/3, sure enough, that's 16. Because think about this, 5 and 10 is 15. 1/3 and 2/3 is 1. So that'd be 15 plus 1, or 16 ounces. So that's the way you want to go through here. Do the same thing for the 20 and the 32-ounce cup. Let's go to the next part here. On average, 300 people attend the game. Of these, you estimate that 3/20 will buy the small size. So we got 3/20 of these people, 300 people, buying the small size. 1/5 buy the medium size, and 1/4 buy the large size. Okay? So we want to find, first we want to fill out the table here, the fraction of the people that purchase this size. So the small size, we said 3/20 will purchase that size. Medium was 1/5. You get the idea now. Now I want to turn this into an actual number of people that purchase this. We know 3/20 of our people that are attending here are going to buy this size. Well, this kind of boils down to I want to find 3/20 of something. To find a fractional part of something, I multiply by that fraction. So I'm taking 3/20 times 300 over 1. I do have a common factor here that will divide out. 20 will divide out nicely there. So 20 goes into itself once. 20 goes into 300. 5 times 3, 15 times. So 3 times 15, that's going to tell me that 45 people are going to buy that size. So we want to do exactly the same thing down here to find out how many people are going to buy the 20 ounce and the 32 ounce size. We're using 1/5 here and I think 1/4 there. Okay. Part B, you calculated the second and third columns. Record the numbers from the previous table. Okay, so we already know this. We already know from the previous table the number of people that are going to buy this size. That we said was 45. We know the ounces of actual soda in that as well. If we go back up here to part 1, we know in a 16-ounce cup there's actually 10 2/3 ounces of soda. So that's how much soda is in the cup, since there's ice in there. So that's 10 2/3 fluid ounces. Now I want to calculate the total number of ounces. So if I got 45 people, and this is how much soda is in each cup, to get the total, I'm multiplying here. So I'm taking 45 times 10 2/3. To do that, I'm going to have to take and write these as fractions. So 45 over 1. I'm going to turn this into an improper fraction. Remember to do that. I first multiply and then add. So 3 times 10 is 30, plus 2 is 32. So that's 32 over 3. Before we multiply this out, let's see if we can divide out any common factors, and we can. 3 goes into itself, and 3 will also go into 45. 3 goes into itself once. It goes into 45 15 times. So I'm just going to take 15 times 32. It's 480. So we need 480 ounces, fluid ounces, to cover all the people, all 45 people that are going to purchase this small size of soda. So you want to continue on in this manner, working this page out. If you do this whole page correctly, you're going to wind up with 2,880 fluid ounces in total. On the first page here, I don't want you to use a calculator. The reason being that I want you to practice using these fractions and practice our operations with fractions. This is a great project for you to practice without a calculator. However, when we get to the back side of this, we're starting to deal with large numbers and decimal numbers and all kinds of things. So I want you to use a calculator on the back side of this class project. There's 2 pages here. Front page, no calculator. Get a lot of nice practice with hand computation. Back page, break out your calculator and start to answer the questions. If you do the whole project perfect, then you'll get down to the very final answer of the class 1.4 class project. You'll find out that your club is going to make 2,393.52 throughout the course of the basketball season. So a couple ways to check your answers. You can check your answer here for the first page, check your answer here for the second page. All right, section 1.5. Ramona owns 24.5 acres of land. So stop right there. See Ramona? See the 24.5 acres of land? 3/5 of the land is planted with winter wheat. So you can see that on her land, 3/5, so not quite half, is planted with winter wheat. 3/10 has got soybeans on it. So try to visualize the wheat growing in her field, maybe just about half of the land, and then 3/10, which is a smaller amount, is planted with soybeans. Once we kind of visualize the problem, now we're ready to answer the questions. What fraction of her land is planted with winter wheat and soybeans combined? So we need to know what these are in total. So we're going to take these fractions and add them. 3/5 plus 3/10. Now to do that, of course, I'm going to have to get a common denominator. My common denominator here is 10, so I'm going to multiply the top and the bottom of this fraction by 2. So times 2 times 2, so we can get this common denominator. So let's see, that's going to be 6/10 here then, 6/10. We don't have to do anything to the second fraction because that already had the correct denominator there. So it looks like 9/10 of her land. So let's see, 9/10 of her land is planted. All right, let's go to part B. How many acres of her land? Well, we know 9/10, so almost the whole thing is planted, right? So we want to know how many acres of her land is planted with winter wheat and soybeans. Well, we know that's 9/10. So what we're trying to do now is we're trying to find 9/10 of something. So to find a fractional part of something, we're going to multiply by that fraction. So I'm taking this 9/10 times 24.5. That's what I want to do. And before I can multiply, I'll have to turn that into an improper fraction. So first I'll multiply, then add. So let's see, it'll be 9/10 times 2 times 24 is 48, plus 1 is 49. So 49 halves. Let's see if there's anything I could divide out here. Nope, no common factors. So I'm just going to multiply straight across. I'm going to get 20 in the bottom. 9 times 49. Let's see, 9 times 49. 441. Now, I think in this problem, if I said 441 over 20 acres, that's really hard to kind of visualize or get a handle on. So it makes a lot more sense to answer this question with a mixed number. So I'm going to go ahead and divide 20 into 441. Let's see, 20 goes into 400 20 times. So that'd be 22 whole times with 1 left over. So 22 and 1/20 acres are planted. All right, let's take a look now at question 23. A 2-cycle engine requires a mixture of oil and gas in order for them to run properly. So telling us about 2-cycle engines. Your lawnmower is a 2-cycle engine a lot of times, maybe a snowblower, something like that. For every gallon of gas, a certain 2-cycle engine requires 1 1/4 fluid ounces. So for every 1 gallon of gas, we require this 1 1/4 fluid ounces. So try to picture like a little 1-gallon gas can. If we were mixing up that 1-gallon gas can for this 2-cycle engine, we'd have to have 1 gallon of gas and this 1 1/4 fluid ounces of oil. So to prepare 3.5 gallons of gas, how much oil is needed? Well, a couple different ways to do this. We already pictured that 1-gallon tank, which was 1 1/4 ounces of oil. So if we had another gallon, that would be another 1 1/4. The third gallon would be another 1 1/4. And then finally, the half a gallon would be half of this 1 1/4. So you can see we're repeatedly adding this 1 1/4 fluid ounces of oil. Well, anytime in math, when we're repeatedly adding the same thing, we use multiplication to get there quicker. So I'm going to take this 1 1/4 and I'm going to multiply it by how many of these things I have, which is 3.5 gallons. So I'm multiplying by 3.5. And again, I'm going to turn these to improper fractions to multiply. So 4 times 1 is 4, plus 1 is 5. So that'd be 5/4. 2 times 3 is 6, plus 1 is 7, so 7 halves. Before I multiply, let's see if I got any common factors to divide out. I don't, so I'm just going to multiply 35 in the top, 8 in the bottom. And again, I think it makes sense to turn this back into a mixed number. So let's see, 8 goes into 35 4 times, which was 32, so I had 3 left over. So 4 3/8 fluid ounces of oil. Oops, that's not oil. Oil. All right, moving on to section 1.6. Questions I usually answer in 1.6 are 28, 30, 32, and 33. So let's see, let's start with 28. Notice I've got this negative exponent up there, and the instructions were to write this or evaluate this without any sort of negative exponents on there. So what I want to do first is rewrite this without the negative exponent. Remember, the negative exponent, all that means is to take the reciprocal of our base, and our base here is -4, And I can think of that negative 4 as negative 4 over 1. So what I want to do is I want to take this negative 4 now, since it's being taken to a negative exponent, and move it to the denominator of my fraction, which will make this a positive exponent. So it would look like this. 1 in the numerator now, and it'd still be in parentheses, that negative 4 would be, but now it's going to be to the positive third power. And so now I want to figure out what negative 4 to the positive third power is. Let's see, negative 4 times negative 4 would give me positive 16. Positive 16 times negative 4 again would give me negative 64. And so since I had this negative 4 in parentheses, I was thinking this. Negative 4 was part of what's being taken to that power. So just to show you how I got that negative 64. So I said negative 4 times negative 4 is positive 16. And then positive 16 times negative 4 is negative 64. And so that's the answer to 28. Let's take a look at question 30 now. Now we want to be careful in question 30 because you see we have a negative exponent here. And a lot of times when students see that negative exponent, they automatically think, flip the fraction. Well, that's not always the case. We only want to move the thing that is actually to a negative exponent. And if you notice, this 3 is not to a negative exponent at all. So that 3 to the second power is going to stay exactly where it is. What we want to do, though, to get rid of this negative exponent down here, is move that then to the numerator. So it would look like this. 3 squared then times 2 to the positive fourth power, all over 1 because I don't have any other numbers left down here in the denominator. So notice I didn't flip it. I just moved the thing that was only to the negative exponent. So now let's evaluate this. First I'm going to evaluate 3 to the second power, which is 9. And then 2 to the fourth power. Let's see. 2 times 2 is 4. Times 2 again is 8. Times 2 again is 16. All over 1. And now I'm going to take 9 times 16. That would be 90 plus 54. 90 plus 54 is 144. Now, it's going to be 144 over 1, but that's just going to be 144. So we're actually left without a fraction here in this one, in our answer. All right. Let's take a look now at question 32. Now in question 32, notice 4 is to a negative exponent, and this negative 5 is all to a negative exponent. So we're actually going to move each of these independently, since I got to move this one to get rid of the negative exponent, and I got to move this one to get rid of the next exponent. It's actually going to flip it, but I don't think you don't want to just say every time you see a negative exponent, flip it. You just want to move the things that are to a negative exponent. Okay? So let's see, 4 to the negative third power, that's going to become 4 to the positive third power when I move that to the numerator. And this guy here will be negative 5 to the second power. All right, let's see. So getting our answer here, 4 to the third power, 4 times 4 is 16, times 4 again is 64. 5, negative 5 squared. Notice this is going to be negative 5 times another negative 5. So that's actually going to be a positive 25 there for my answer. All right, let's take a look now at question 33. 33, we have a lot of stuff going on. We've got this negative that's going to the whole thing. When it's this situation, then that would tell me to flip the whole fraction, since this whole fraction is getting taken to this negative exponent. But I've also got inside of here things that are taken to a negative exponent as well. There's two ways to do this. You could deal with this one first, then deal with the inside, or you could deal with the inside first and then deal with that one second. Generally, what we do in math is simplify what's in the parentheses first. So that's how I'm going to solve this, but you could do it the other way as well. So inside the parentheses, I'm going to get this down to a single answer here, or simplify it the best I can. Notice this 5 is to a negative exponent, so I got to move that thing to the numerator. This 2 is to a negative exponent, so that tells me I got to move that to the denominator. So I'm going to keep the parentheses and the negative 3 on the outside so I don't forget about that. Now it's going to look like this. 5 squared over 2 to the first power. Well, 2 to the first power is just 2, so I'm going to write that as just 2. Now that I've got this figured out, well, I almost figured out. Let's keep going here. So I'm going to square that 5. So it's going to be 25 over 2 to the negative third power. We'll come up over here to finish this. Now let's deal with this negative exponent here. So this negative exponent is going to the whole fraction. So this is the time, or the only time, where I flip the whole fraction. So that's going to be then 2 over 25. And what that will do is get rid of the negative on that 3 as my exponent. Now I want to take each of these things to the third power. 2 to the third power, which is going to give me 8. And then 25 to the third power, which is going to give me a big number. 25 times 25 times 25 is going to give me 15,625. Now, you might think about simplifying that fraction, but it's not going to happen. And here's how I know that, because really if I think about this fraction in the numerator, oops, guy moved on me there. In the numerator, I had 2 times 2 times 2. I'm going to have to go to a different spot to do this. Funny things are happening. Let's come right up over here. In the numerator, I knew I had this. 2 times 2 times 2. In the denominator, I had 5 times 5 times 5. Those were the numbers I was multiplying. And since there aren't any common factors here in the values that I'm multiplying, I know then that my answer down here is not going to be able to be simplified. So that's my final simplified answer on that. All right, section 1.7. I usually answer questions 10 and 21. So let's look at 10. So we're following the order of operations here. PEMDAS, or please excuse my dear Aunt Sally. And we got to be careful about one thing. Multiplication and division tie. I don't do multiplication before division. Addition and subtraction also tie. And so these little arrows are telling me that in a tie, work left to right. So if I have both multiplication and division in a problem, work left to right. If I have both addition and subtraction in a problem, work left to right, because those are a tie. And that's what comes up in question 10. People forget to do this little step right here, because notice I have division, multiplication, and division. So these tie. And what you students do a lot of times and make a mistake is they multiply 2 times 3 first. Because please excuse my dear Aunt Sally. Well, the reason we have to excuse dear Aunt Sally is she's screwing our answers up. If you don't recognize that there's a tie with multiplication, division, addition, and subtraction. So in a tie, work left to right. So here we're doing this division first. So 24 divided by 2 gives me 12. And then 12 times 3 gives me 36. So notice I'm just working left to right. 36 divided by 2 gives me 18 for my final answer there. If we were to multiply first, we'll get a different answer than 18, and it won't be correct. So be careful of that. All right, next question I get a bunch is 21. And usually what happens with 21 is students try to do more than one step at a time. So here's the go-to mistake on this. They don't work on the outside. They go to work inside these inner parentheses, which is what we want to do. And then you say, okay, look, inside this brackets here, I got another set of parentheses, and I know that I need to subtract that. 6 minus 3, and that step is absolutely correct. 6 minus 3 is 3. That's what we want to do first. Here's the mistake they make, though. Then they also subtract 4 minus 2 and write that answer down here, but that's a mistake because you see, this is multiplication right there, and that's what I'm going to want to do next, not this subtraction. So if you try to do 2 steps at once, a lot of times you make a mistake here. If you just do 1 step at a time, you won't make that mistake, because watch, if I rewrite the problem now, 4 minus 2, bracket, being careful here. Now if I look inside the bracket, once I've written it, there's no way I'm going to do this subtraction next. I'm going to say, oh, I got to do the multiplication next. So make sure, especially on our test, you're writing down all these steps. And you won't make that mistake. So 4, now I'm going to do 2 minus 3 is 6, so 4 minus 6. Still working inside those brackets. 4 minus 6, well, that's going to give me negative 2. Now let's see what I have left. I have subtraction, multiplication, and division. Well, multiplication and division are coming next, and I want to do the multiplication because that's happening first, left to right here. So I'm going to have 4. Now think about this as negative 3 times negative 2. So negative 3 times negative 2 is going to give me a positive, or plus 6. Division next. 6 divided by 2 is 3, and then 4 plus 3 is 7.